Welcome to a lesson on simultaneous equations, solving simultaneous equations graphically, which is exercise 9E of our current textbook, the Cambridge one. So let's get started. Now, I'm going to start from the basics, I guess. Every point in a straight line can be described by coordinates, right? So if this is a straight line, then this straight line, what is this straight line? This straight line are all the points, all the different numbers that satisfy this rule of y equals 2x plus 1. Y equals 2x plus 1. That's a rule. It says that y is an output, y is an answer. When you have, well, y is equal to 2 times a number plus 1. Now, you can put any number into x that you want. If you put in 0, 2 times 0 is 0 plus 1. So I guess what we're saying is, let me just pull out my pen. If y is an output, that is an output. It's an answer. It's what you get out, depending on what you put in. What you put into the rule, 2 times x plus 1. Now, obviously, x is the input. It's what you put in. And if I put in, let's say I put in x equals to 0. So if I put in x equals to 0, what will be my output? Now, when we write coordinates, that's our input. And it's known as the x coordinate. And then over here will be our output. Will be what we get out, and it's known as the y coordinate. So if I put 0 over here, I'm going to get an output of 1. And I can graph this. I can say when x is 0, y is 1, and I can put a dot there. And then I can say, well, hang on, what if my input, what if I put in 1? What if I put in 1? And then you could put in 1, and what output would you get? So let's say 2 times 1 is 2, plus 1 is 3. And so when x is 1, y is 3. And as you can see, every single input I'm putting in, it's happening to be on the line. And the line is, in fact, all of the different numbers, combination of numbers, which will satisfy this rule. Okay, now you could put in 1.5. If I put in half, if I put in 0.5, my output will be 2. Let's try that. If I put 2 times a half, what's half of 2? 1. 1 plus 1 is 2. And as you can see, it was 2, as expected. So with this line, we can make predictions because we know the rule, and we can view the rule graphically. And here's a bunch of different coordinates. We can write, normally, I'm sure you're used to writing it like this, x, y, and then you sub in, it's called a table of values. You can put 0 and it'll be 1. If I sub in 0.5, we figured out it was 2. When I subbed in 1, I got 3, and so on. You can also draw it vertically like this, just different way to write it down, I guess. And the advantage of this is you can actually get coordinates, -5, -9. When it was 0, it was 1. When it was 1, it was 3. And hopefully you can see the relationship. It's just generally I'm discussing lines, okay? And the key idea is that every point on this line corresponds to a coordinate. So for example, if I were to pick this point, the coordinates of this point will be -2, comma, and then down it's -3. So -3. So just so you can see it more clearly, -2, comma, -3 is that coordinate, that point on the line. Moving on. So obviously we're going to be doing simultaneous equations graphically. What that means is we're going to have 2 lines. If you ever have 2 lines drawn up, then as a general rule, they will meet somewhere, unless of course they're parallel. And parallel lines, by definition, never ever meet. But if they're not parallel, then 2 lines will always meet somewhere. And the point of intersection, the place where they meet, it has a lot of uses in the real world. It's used different places, such as, for example, businesses when they're talking about breaking even. If you wanted to analyze when you will actually start to make a profit, then what you can do is you can draw a graph showing your costs. So for example, your costs might be like that. And you can graph your sales. So your sales might be like this. And the place where they meet is the place where you start to make a profit. This is going to be your profit all the way there. And all of this is your loss. And that place of intersection is called a break-even point. Break-even point. And it's definitely used a lot. If you do business studies next year, which I'm assuming most of you will be, it's in the preliminary course and it's also in the HSC course, so you'll definitely be using it. There's not much maths in business studies, but a lot of the things that we do in maths have applications in a variety of different subjects, including science, biology, chemistry, and business studies, economics, a bunch of different subjects. That's why it's here, right? I know a lot of you guys like to ask, when will we ever use this? But it actually is used a fair bit. It's just that we need to learn it in order to use it. And if we don't learn it, then we'll never be able to do the subjects where it is actually used. Anyway, moving on. So if we draw two lines and they meet somewhere, they'll meet at a certain coordinate. That's known as the point of intersection, such as over here. And clearly we can see the point of intersection of these two lines is 1,3. We can look at it visually, graphically. We look at it and we say, okay, this is where they're meeting. Clearly, that's not really, very hard to see. That's where they're meeting. What's the coordinates of where they're meeting? The coordinates of the meeting place. And x, y, x is left, right. So it's clearly 1 here, 1. And how up, down is it? 3. So 1,3 is their meeting point. And we have solved these two equations simultaneously. That's what it's known as, solving simultaneously, finding their place of intersection where they meet. So let's have a look at some of the questions you'll be, the types of questions you'll come across in this exercise. State the point of intersection for the following lines if there is one. So over here, they clearly, where are they meeting? 1, 2, 3. So we can just draw a line up. And so clearly the coordinate of the point of intersection is 2, comma, and then we have to go, the y-axis is going to be 3. So as always, that is x, and this is y, as you can see over here as well, x comma y. So you find whereabouts on the x-axis. First number is going to be on the x-axis, and that's clearly 2. The second number is going to be related to the y-axis. So look on the y-axis, and related to that meeting place is obviously 3 there. So 2, 3 is the point of intersection. Now we move on to part B. Part B, clearly these lines are parallel, so no meeting point, as they are parallel. And sorry, my handwriting is a bit messy. Obviously, I'm using the graphics tablet thing, so I can't really see what I'm writing. It's just hard to write neatly. Moving on, find the point of intersection, x comma y, of y equals 2x plus 4 and 3x plus y equals 9 by sketching accurate graphs on the same axes. So this is building on your knowledge of being able to sketch a line. So, you know what, I might just use this feature. Let's hopefully it turns out good. Oh, great. This actually works out really good. So let's graph these. Y equals to 2x plus 4. So anytime there's two ways. Now, does someone remember the way I taught you? Did I use the x equals 0, y equals 0 method, or did I show you the y-intercept and then the gradient method? Obviously, I know both. I just don't want to confuse you guys. No one's really speaking, so I guess I'll use the gradient method. So let's see. The y-intercept is 4. So I go to 1, 2, 3, 4. and I put a dot there. There's a dot at the y-intercept. Y-intercept. And the gradient is 2. That means the rise over run. Gradient obviously is rise over run. That's the gradient. Equals rise over run. And over here, the gradient is 2. It means the rise over run of 2 over 1. 2 is, you can write 2 as 2 over 1. 2 divided by 1 is still 2. I haven't changed the number. So rise of 2, so it's going to go up by 2. It's going to go across by 1. Put another dot there. And just double checking, that is a positive gradient. And therefore, I can now just simply line up these dots. I can draw a straight line through them. So I might just use my tool here. Yeah, as good a line as any. And let's have a look at the next bit. We also have to graph the second line. Now I'm going to rearrange, make y the subject. Y is equal to negative 3x plus 9. Okay, clearly I'm going to have to extend my axes. Unfortunately, hang on. Yeah, looks good. And it was going to 1, 2, 3, 4. So the line was there. And swipe off this stuff. Does it go up to 9? 1. So okay, so what I'm doing is basically the y-intercept is clearly at 9, and my graph wasn't big enough, which is why I'm resizing my graph. So it's going to 1, 2, 3, 4, 5, 6, 7, 8, 9. Still not long enough. So I might just extend this some more. And this was made, the y-intercept was 4. So I'm just making sure it's still at 4. Okay. Hopefully that should be long enough now. All right, so that's a 4, 5, 6, 7, 8, 9. That's 9. My y-intercept's at 9, so I'll draw a dot there. And it's negative 3x, which means it's going like this, if you guys remember. So this is the y-intercept, and it's going to go down. So it's negative 3 over 1. Instead of rise over run, it's going down by 3. So 1, 2, 3, and going across by 1. So over there. And I can draw a line here. There we go. And by sketching accuracy, we have to find the point of intersection. Point of intersection, this is clearly 1. That is 4, 5, 6, 6. And so by graphing straight lines, we can visually look at the place of intersection. The point of intersection is 1, 6. And that's how you solve simultaneously graphically using the graphical method. Use visual inspect. So someone's asked why it's negative 3x. And so let me just explain this for a second. We have 3x plus y equals to 9. I want to have y by itself, because if you're going to use the y equals to mx plus b method, in other words, the y-intercept and the gradient method, then you need to have y by itself. To have y by itself, I need to move the 3x to the other side. So I'd subtract 3x on both sides, and you're left with y is equal to negative 3x plus 9. That's a positive 9. It's clearly not a negative 9. I mean, you could write 9 minus 3x as well. There's nothing wrong with that. It's perfectly fine. I just chose to write the negative 3x first, and that's a positive 9. So you can write plus 9, negative 3x plus 9. I haven't really changed anything. And the reason I chose to do that is so that it looks a bit more like y equals to mx plus b. It's just personal preference. You won't get it wrong. It's just like the gradient is negative 3. That's really the point. The gradient is negative 3. It's going down by 3 and across by 1. And I've down by 3 across by 1. And that's why it's negative 3x. Hope that answered your question. I'm going to move forward. Feel free to ask any questions. You can unmute yourself and ask. But do be aware, it does go on YouTube. Obviously, it's private video, so no one will see it. The public will not see it. It's pretty much only for our class, maybe for future classes, but doubt it. If you're at all conscious, please send me a message. through chat. I won't mention your name. I'll just answer the question. So there's no need to be embarrassed. No one sees it but me. Moving on. Actually, that's it. That's the chapter. What I might do is I might do one more question because as you know, just in general, I feel like our class can be a bit weak with algebra and equations and so on. So I might just get one more question, 1 second, and I might just show how to graph and then find the point of intersection. So let me look at a question that's not part of the homework. Question 7 and question 8. Let's look at question 9. Why not? Okay. Okay, so how would you do this question? Let's see. Graph these 3 lines on the same coordinate axes by plotting the axis intercepts for each of those. All right, just saving a bit of time, so I just don't have to regraph the whole thing and resize and so on and so forth. Okay, so y equals to 3. Now, if x was equal to 3, you'd look on the x-axis. This is y equals 3, so you're looking on the y-axis. 1, 2, 3. That's 3. And if y is equal to 3, then I'm going to graph this in blue. And that's just going to be the straight line y equals to 3. So this is how you graph. You know what? That's going to be a bit confusing with the x-axis. So I might graph it in green. Of course, that's not a straight line. And look, in this chapter, the more accurately you graph, the easier it'll be to solve the question, okay? That's in green. And then in red, I might do x plus 1. Y equals to x plus 1. So if you have y equals to x plus 1, the y-intercept is clearly at 1. So I'll put a dot there. And then what's the rise over run? Obviously, the coefficient of x is 1 here. And rise over run is 1 over 1. 1 over 1. Because the number 1 can be written as 1 over 1. If you have a number by itself, 7, you can always write it over 1. If you have a number 10, you can write it 10 over 1. It doesn't change. So in this case, we have 1, we can write it as 1 over 1 because 1 divided by 1 is equal to 1. I'm not changing the question. So the rise is 1, the run is also 1, 1 over 1. So it's going up by 1, across by 1, and a dot there, and a dot there. So it's going every single time, it's going to go up by 1, across by 1, up by 1, across by 1, like this. And I have a sneaking suspicion that the meeting point is going to be there. But let's keep working. Y is equal to 1 minus x. So I wipe this off. I've done it. And I'll do this one. I wonder if I can change the color of the pen. Color and thickness. Might make it purple. Why not? Love purple. Purple's a great color. So now I'm going to do y equals to 1 minus x. All right, so 1 minus x, what I might do is I might rearrange and write the letter first. So y is equal to negative x plus 1. That is a positive 1. It's a negative x positive 1. All right, so now y-intercept is 1 again. Okay, it's still 1. And the rise of a run, obviously the number next to x, when there's no number, it's always 1. And negative 1, if you have a number by itself, you can always write it as over 1. So rise, run. It's negative, so it's going to go down by 1. Go down by 1 and across by 1, like there, like there, like that, and so on. So I forgot to join up the previous line. And I'll do that now. So red line, where is my line? Here it is. And there we go. And so I have graphed the 3 lines. Okay, let's look at the question. Write the coordinates of the points of intersection. Okay, so what is the meeting point over here? It's meeting at 2, 3. That's one meeting point. The other meeting point obviously is 0, 1. And the third one is over here. That's negative 2, 3. So negative 2, 3. the 3 points of intersection, and I'll highlight them. So that's the red and the green line. This is the red and the purple line. That's the purple and the green line. And I've written down the points of intersection. Find the length of each line segment formed between the intersection points. So what is the distance? What is the distance between the meeting points, I guess? Okay, so what I might do is I might zoom in and I'll just show you what I'm thinking. Okay, so to find the distance from, that distance there, we can use Pythagoras theorem, right? And might take a bit of thinking, but if you think about it, when we have done this, but think about it in terms of a triangle. That is a triangle, right? And the height of this triangle is 2, 1, 2. And the width of this triangle is also 2. So if you're a triangle, and we're gonna use Pythagoras theorem here, right? That's clearly a right angle, and 2 and 2. And using Pythagoras' theorem, says this squared plus this squared, that's 4 plus 4, which is going to be 8, is going to equal to that squared. In other words, this is square root of 8. And so this distance is square root 8. Now, this is also 2 by 2, so that's also going to be square root of 8. And this distance over here, I mean, that's just a horizontal distance. We can count the squares. 1, 2, 3, 4. So that's 4. Square root 8, square root 8, and 4. That's not. So this is a harder question. This is a problem-solving question. Find the length of each line segment. So square root 8, and it was 4. What type of triangle is formed by these line segments? What do you call a triangle which has 2 equal sides? And I'm sure you know it is an isosceles triangle. Isosceles triangle. And we're done. So hopefully the main thing you should have gotten away from that was graphing a line and then examining it visually to find the point of intersection. If you have a grid paper, you should be using that. Be as neat as you can possibly be when you're drawing the graphs of the lines so that you'll be able to see the points of intersection very clearly. So best of luck with that. I'm going to stop the video now. And then if anyone has questions or wants me to do more examples, I'll be more than happy to.